welcome to the channel, and today I will show you how to perform a supervised image classification using Landsat 8 image in Google Earth Engine. So let's get started. So to perform a supervised image classification using Landsat 8 image, first we have to define our region of interest. Now let me show you how to define our region of interest. So now let me select the study area, Chennai. Let me get to this study region. So this is Chennai. So now to define this as my study area or my region of interest, I have to just go to the option called add marker. Now let me click this. Now click place a marker here. So now this will be our study area. You can also use this polygon option also. So now in this video I will use only the point option. So now I selected, I placed a marker in my study area, that is my region of interest ROI. So now that is clearly indicated here. We define a variable called geometry with the latitude and longitude of the study area. So now let me rename this. So go to the option and let me rename as ROI. So region of interest I defined as ROI. Now click OK. You can also choose your desired color. So now let me choose a color. So I've chosen a color, click OK. So we have our ROI, the region of interest with latitude and longitude. So now let us perform our supervised image classification. So to perform a supervised image classification using Landsat 8 image, first we have to load our Landsat 8 image into Earth Engine. So to load our Landsat 8 image into Earth Engine, we have to define a variable called image equals to image collection Landsat 8 collection 1 tier 1 surface reflectance. So this is the code will import our Landsat 8 image into Earth Engine. Next we have to filter with specific date. So to filter with a specific date, we have to define dot filter date 2020 January 1 2020 December 31. So next we are filtering with our study area. So that is ROI represents our study region of interest. So that is defined here. So this will be our study region with the latitude and longitude. So to filter with the study area, we have to define dot filter bound ROI. So next we have to, in order to reduce the cloud contamination, we have to define this function, that is dot sort cloud cover. So referring to the cloud percentage, and dot first function. So as this function, what it does is it gives us a low cloud contaminated Landsat 8 image. So next we have to define a visualization parameter for our Landsat 8 image. So to set a visualization parameter for our Landsat 8 image, we defined a variable visualization parameter true color composite. So equals to bands, band 4, band 3 and band 2. So band 2, band 3 and band 4 are 30 meter resolution. And we are set to a minimum value of 0 and to a maximum value of 3000 and a gamma value of around 1.4. So now to add this layer into Earth Engine, we have to define map.addLayer image, set the visualization parameter, that is we have defined our visualization parameter here, that is represented here, and output the layer name as Landsat 2020. And next to center our layer, we have to define map.centerObject ROI and with a zoom level of 8. So now let us run this code. So to run this code, go to the option called run script and click run script. So now let us visualize our Landsat 8 image for our study region. So now we can clearly able to view that this is our Landsat 8 image of 30 meter resolution. With the 3 band, we are using 3 bands, that is true color composite of Landsat 8 image. So now let me zoom into this region. So in this satellite image, we can able to see variety of features. So here's a water body, that is a lake, and here there is a ocean, and we have several water bodies here that is indicated. So this is a water body, and let me zoom here. So now let us view this urban settlements. So this is an urban area. It is highly populated, and we have several rivers, and we have a canal system here, and we have a water body, lakes. We have, this is a lake, this is a lake, this is a settlement, and we have a beach and a vegetation. So we have few areas where we can clearly able to visualize the vegetation. Now let me show you that. So this is a spot with the high vegetation, which is clearly indicated in green color. So this image is of 30-meter resolution. So this is a vegetation area. So let us perform. So next step, we have to provide a training data for our model, that is our supervised image classification model. So in order to provide a supervised image classification, to perform our supervised image classification, we need to provide our training data to our supervised classification model. So the training to in order to import the training data. So to perform supervised classification, we have to give a training sample training data into for our model. So that is, we have to provide for each of these features. That is, for example, water body is a feature, and settlement urban area is a feature, and the barren land is another feature. Vegetation is a feature. So for each of these different features, we have to provide a sample or a training data to our model. So to how to perform this, how to create a training data. So now let me show. I will show you how to create a training data to our supervised classification model. So go to the option called geometry imports. Now click new layer. So now we have our new layer that is called geometry. So now go to the option called edit layer properties. So now this is our configure geometry input. So now let me enter the name. So now let me enter the name as water. So now we're going to provide a training data for our water bodies in our study region. So import as feature collection, and properties. Make sure that you click you type as class. Now in the value section, enter the value as 0. So for each of this class, we have to start with the value 0, 1, 2, 3, and 4 for each of our different features, that is water, urban areas. So in case water, we are giving a value of 0. So in case in a build up, we're going to give a value of 1, and similarly for vegetation 2, and for barren 4. So now let me click OK. So now you can also choose your color. So let me choose the color for a water body. I will choose a blue color. So now click OK. So in this video, I will show you 4 different feature classes. We're going to perform a supervised image classification using 4 different features in our study region. So now we can clearly able to view that this layer in bold color. So you can turn this off just by clicking it. So to turn this layer on, click this. So it will be in the bold color. So now let us select the water bodies. So that is, we're going to select a training sample for our supervised image classification model. So now let me click different part of the water bodies, training data. So this point data will be used as a training data. So now let us click some more in the lakes. Let us take a training data from our lakes. Click this. So this is a canal. This is about the Kusastalaya river, and let me show you that. So this is a canal system. So this is a Buckingham Canal. You can also select this as a training data. Now let me select this part of this region, water body. Now similarly, let me select this lake. So there is a many water bodies in our study area. Make sure that you select all As you can give a more sample data, your supervised classification will be more accurate for each of your features. So this is another water body. Now let me to in order to check whether it is a water body or not, go to this layer, turn this off. So now you can clearly able to view here. So this is a water body. Let me turn this layer on again. So now let me select the other part of this. So some areas there is also vegetation has been covered. So make sure you only select the water. So there is another water body. There is a lake. So similarly, you have to select all the part of your study region in order to make more accurate supervised classification image. So this is a Pulicat lake. Now let me take the training samples from this lake. So this is one of the biggest lake in our study region. So now I have selected training sample training data for our classification model. So in the different part of our study region. So now let me create another layer. So to provide a training sample for our build up areas. So now go to this option. Now click a new layer. So click this option called edit layer properties. Now enter the name as build-ups. Choose the import as feature collection and properties class and enter the value as 1. So we already mentioned value 0 for water bodies. So for build-up we are mentioning as 1. So click OK. So before that, let me choose a color. So for build-up areas, let me select a red color. Now click OK. So now let us provide a training data for our build-up. So make sure that when you're giving your training data, make sure that there should be a minimum of 50 points. So now let me give some training data for our build-up areas. So now you can clearly able to view there is a different high percentage of settlement density is observed in this part of the region. So now let me show you. Click the satellite. Let me turn this layer off. So now let me zoom in. So now you can clearly able to view there is a different amount of settlements that is observed in this study region. So now let me take a sample training data from this region. Let me turn on this Landsat. Now let me click here. Just make sure that you are giving your training sample that is of settlement, that is a build-up areas. You can confirm using by turn off this layer, so you can visualize the different settlement number here in Google Earth Engine satellite. So now let me turn this on. So this is now Landsat. So now let me select few more areas of the settlements. So now here there is a settlement. Here there is a settlement. So you can also confirm your settlement by using this. Turn this off layer and go to the satellite mode. You can confirm the settlement areas in this region. So now I have taken around 78 points for sample training data for our build-up areas in the study area. So now let me select another layer. Click this. So now let me select another layer, that is vegetation. So go to the edit layer properties. So now let me name as vegetation. So I have named the class as vegetation. Import as feature collection. Now go to the properties. So now let me enter the property as class. Now let us enter the value as 2. So now click OK. Before that, let me choose a color for a vegetation. So vegetation, let me select. So let me select a dense color. So now click OK. So vegetation. Now let us provide some training data. So now let me select a vegetation area. So this green patch is an indication of vegetation. So now let me select that region. So here there is a green patch. So now let me select that green patch only. So now let us select, let us provide more training sample for our vegetation. So there is another green patch here. Let me select. So there is a green patch here. So now I have selected a training data for our vegetation. So now let us select our training data for our barren areas. So now let me select a barren areas in this image. So now let us create a new layer. Go to this layer section, new layer. So now edit layer properties. So now let me enter as barren. Now select the import as job, select as feature collection. So properties, class. Enter the value as 3. So now click OK. So now let us provide a sample, training sample for our barren areas in this study region. So now let me take the training data of this barren areas. So selected different barren areas for our training sample to import it as our training sample to a model. So select as minimum as 45 points. So here we have 46. Let's select 4 more areas. So we have 50 points. So we have provided a training sample with training samples for different classes for water body, build-up, vegetation, and barren lands. So now we have created a different training data for our Landsat 8 image to import this training data into our supervised image classification model. So we created for training data for water, build-up, and vegetation, and barren areas. So here the red indicates build up and blue indicates. So now we have created different training data in order to import our training data into our supervised classification model. So water, build up, vegetation, barren. So next step we have to create a training data and extract the bands from Landsat 8 image. So, to import this training data and extract the Landsat 8 band from the Landsat 8 image. So in this video, we will import our training data and extract the Landsat 8 bands. So to import our training data into our supervised image classification model, we have to define a variable called labels equals to class. So you can able to remember for each of the samples, we have mentioned the property as a class and the number and the value as 0. So here we are mentioned as class. So now created a variable called label equals to class. So now next we have defined a variable called bands. So now let us choose our required bands from our Landsat 8 image. So in order to choose the bands from our Landsat 8 image, we define a variable called bands equals to band 1, band 2, band 3, band 4, band 5 and band 7 from our Landsat 8 image. So we are selecting band 1, 2, 3, 4, 5 and 7 from our Landsat 8 image. So we are using the specific number of bands from our Landsat 8 image because we don't require to select all the 11 bands. So instead we require only the 6 bands to perform our supervised image classification. For that, we defined a variable called bands and selected band 1, 2, 3, 4, 5 and 7. So now to extract this bands from our Landsat 8 image, we defined a variable called input equals to image. So here the image refers to our Landsat 8 image. So that is defined here, the variable image, that is Landsat 8. So we defined a variable called input equals to image dot select bands. So the band refers to this variable bands, that is band 1 to 5 and band 7. So in the next step we're going to import our training data into our supervised classification model. So to perform that, so we can we have to you can able to see here, these are the different feature classes, that is our training classes. So for water we have around 54 elements. For build-up there is 78 elements, and for vegetation is 55 elements. So each of this element we have to merge together. So in order to perform to import our training data into our supervised classification model. So to merge that, we defined a variable called training equals to vegetation. So here the vegetation refers to this specific variable vegetation, and similarly the barren here refers to this specific variable barren, and water body refers to this one. So the water here refers to this variable called waters, and the build up here refers to this variable, this one, build up feature class. So let us merge all these elements together. For barren we have to merge these 50 elements together, and for vegetation we have to merge this 55 elements, and for similarly build up and water, for water we have to merge this 54 elements, and for build up we have to merge this 78 elements to combine together this training data. So this specific function we are used to merge this training data together and import this training data into our model. So for that we defined a variable called training equals to vegetation dot merge barren, merge water, merge build up. And to visualize this function, we have defined print training. So to visualize this result of this training data, we define print training. So now let us run this code. Go to this option called run script and click run script. So now we can able to see in the console section. So we have our result of this training data. So let us visualize it. So we have different features. We have total 237 elements. So when you add all these elements together, you'll get around 237 elements. So now let us open this. So let me check this out, feature. So go to the property section. So this indicates a class 2. So class 2 here indicates, so this is class 0, class 1, class 2 and class 3. So class 2 indicates the vegetation. So this indicates the vegetation. And let us view other classes. So this is also class 2. So this is class 0. The class 0 indicates water. So next we have to overlay our training points on the Landsat 8 image and to extract our Landsat 8 bands. So for that, we defined a variable called train image equals to input dot sample region function and collection referring to training. So here the training refers to this training. So here where we have merged our training data together for vegetation, barren, water body, and buildup. And properties we given label. So label here refers to this specific variable, that is refers to our class. And next scale refers to the spatial resolution of our Landsat 8 image. So that is a 30-meter resolution. So previously in the features, so we can able to see only the property section. We can able to see only the class. So in this way, in this section, we can able to view the bands. So now let us run this code. So let me close this. So go to the option called run script and click run script. So we are visualizing the result of our train image from this variable. So let us view this. So go to the properties, band orders. So now we can you can clearly able to view we have our bands here. So in the feature section, let me select this and go to the property. So now you can clearly able to visualize we have extracted the training data as well as our Landsat 8 bands. So band 1 to band 5 and band 7. So the next part of the step is we're going to perform some accuracy assessment. So before we're going to perform some supervised classification, we have to check for the accuracy of our data. So in order to perform our accuracy assessment for our data, we are using 80% of our training data for classification and 20% of our data for validation. So before performing our supervised classification, we need to assess our accuracy of our training data. So to assess the accuracy of training data, we defined a variable called training data equals to train image. So here the train image refers to this specific variable train image and dot random column. So it will generate a random column. And next we defined a variable called train set. So train set refers to used for our so the train set will be specifically used, that is 80% of the data will be used for training data. That is a variable we define train set. So in this specific variable we have 80% of our data will be used for our training data in a variable called test set, where the 20% of our training data will be used for validation of the data. So for training, we defined a variable called train set equals to training data. So refers to this variable training data dot filter less than random 0.8 refers to 80% of our data will be used for training. And for next variable, we define this variable test set equals to training data. So this refers to this specific variable. And dot filter greater than or equals to random 0.8. That is 20% of the data will be used for validation. So now let us perform our classification. So to perform classification, we defined a variable called classifier. So we defined a variable for classifier equals to dot classifier. We are called the Earth Engine classifier. So next we defined smile card. So smile card function is a regression tree model function, and it uses a regression tree model to classify our classes, that is our supervised classes. And dot train, we are referring to train set. So train set here refers to this particular data, that is our training data, that is our sample training data. And the label here refers to our class. So the label here that refers to our class. So here, so class we have this particular, that is water, buildup, vegetation, and barren. And last, bands. And bands here refers to this our Landsat 8 bands. So that is here. So this is our Landsat 8 bands. So the next step will be actually classifying our image. So what we're going to do is we're going to classify this Landsat 8 image into four classes. That is, let me show you that. So water, build-up, vegetation, and barren land. So we're going to classify our Landsat 8 image into four different classes based on our training samples. So now we're going to classify our Landsat 8 image into four different classes based on our training data. So for that we defined a variable called classified equals to input. So here the input refers to our Landsat 8 image dot classify function. So we are referring our classifier. So we have defined our classifier here. That is our classification model. So this is our classification model. I'm just define classify function and referring to this variable. So this is a variable containing our classification model. So to view this details of this classified image, we have defined print classified dot get info function. So now let us visualize the result of this classified image. So go to the option called run script and click run script. So now let us view the details of our classified image. So we have bands and properties, system footprints, coordinates. So it is defined as classification. So these are the different 21 elements. Okay, so this property and so in classification bands we have our classification and also property of this image, the coordinate, that is projection. And so now let us visualize the image of this classified image of our Landsat 8. So to visualize our classified Landsat 8 image for our Landsat 8 image, we have defined a variable called land cover palettes. So to visualize our satellite image, that is to visualize the classified image of this Landsat 8. So for that we had to define a variable called land cover palettes. So for that we defined a color for each of this different so now let me change to water. So for water we define for this specific color, and for build up we define this color, and for vegetation this, and for barren we define this color. So now to add this layer into Earth Engine and let us visualize our Landsat 8 image of classified one. So for that we define map.add layer classified. So the classified here refers to this specific variable, and palettes refers to our visualization parameter. So the palette here refers to our visualize, that is land cover palette, this variable. So for visualization purpose, for with a minimum of 0 and to a maximum of 4, and output the layer as classification. So now let us run this code. Let us convert our Landsat 8 image into a classified image. So let us run this code. Go to the option called run script, click run script. So now let us visualize our result. So we have used four different training samples, that is water body, vegetation, barren, and urban area. So now let us view this. So we have our water body that is indicated in blue color. So that is clearly indicated here. So now let us view this. So here it indicates water body. So this is a lake. So that is indicated in blue color. And similarly, let us view this. What does this color refers to? So this color refers to vegetation. Now let us conform it. So now let me go to the classification, turn this off. So it is the vegetation. So this specific color indicates vegetation, and red color indicates the urban area. So now let us view this. So this is all the urban areas. Now let us view the classification. So the classified also indicates it is of urban area, that is shown in the red color. So now let us view what is this. So we have our lakes. So in this study area has many lakes, and let us view what this color refers to. So that particular color refers to barren areas. So clearly indicated in this color. So the classified image clearly shows the water blue indicates water bodies, and this specific color green indicates there is a vegetation, and this light green indicates of barren areas, and red indicates the urban areas. So you can add more training samples. There is many classes. For this video, we just used only 4 different classes: water body, buildup, and vegetation and barren. You can add many other classes to this classification model. So you can add many features. So we have just used water buildup and vegetation and barren. You can also select many features in your study areas in your study area. So we have converted that we have transformed our Landsat 8 image into a land cover image. So you can also turn this training data off. Go to this geometry import, turn this off. Turn this off. So now we have converted our Landsat image into a classified image. So next we have to assess our accuracy of this classification. So now for that, let us perform that. Let us assess the accuracy of this classification. So next we have to test the accuracy of our classification. For that we have to perform an accuracy assessment. So to perform an accuracy assessment and classify our test set, previously we have defined there is variable called test set. The 20% of the variable will be used for the validation purposes. So for that, we're going to use the test set variable. So the test set variable will be used here and get the confusion matrix. So to assess the accuracy, we have to define variable called confusion matrix equals to confusion matrix test set refers to this variable. Dot classify the classifier. So here the classifier refers to our model, that is our classification model. Let me show you that. So this is our classifier variable. So next we have to create our error matrix. So here we have to provide 2 different parameters. That is our actual parameter, that is our classes, and our predicted one. So predicted here refers to our classified image. So actual will be our training data and our predicted one will be our classification. So in order to assess the accuracy of our classified image. So basically this one will generate our confusion matrix. So now let us print our confusion matrix. So for that we're gonna use the print confusion matrix and mention as confusion matrix. So the variable confusion matrix. So here it refers to this one. So now let us run this code. Go to the option called run script and click run script. So now let us view in the console section. So now you can able to clearly view in the console section. We have our confusion matrix. So that is for our 0 refers to our first training data, water, buildup, vegetation, and barren. So 0 refers to water, buildup, vegetation, and barren. So this is the confusion matrix. Now let us check the overall accuracy of our model. So let us check that. So to do that, we have to define print overall accuracy confusion matrix dot accuracy function. So now let us run this code again. So let us view in the console section. Yeah, we have our confusion matrix and our accuracy. So the accuracy states that the overall accuracy is around 83.63%. So it is around 83% accurate. So accuracy also can be measured using this specific function. So the overall accuracy of this model is there is 83%. So next we have to export our classified image of our Landsat 8. So to do that, let me show you that. So to download or export our classified land use land cover to our Google Drive, so for that we have to define export.image.to drive, and we have to give some parameters like image is of classified, description, that is Landsat classified cart. That is a Landsat classified cart. So the cart here refers to classified and regression tree. So this specific technique that is called, that is cart classified and regression tree. So the scale is of 30-meter resolution, and region, that is a static region, is ROI, and the maximum, we have to specify a maximum pixel, that is 1 is to 10 power 13. So to download or to export our classified image to our Google Drive, all you have to do is go to the option called Run Script and click Run Script. So now we can view here. So we have our image, our classified image, as well as our Landsat 8 image. So go to the task section. So to classify, to export this classified Landsat 8 image to your Google Drive, all you have to do is click Run. So let me click that. So here the windows, that is a window popped up. So to export this, all you have to do is go to the option called click Run. So now you can able to view here. So the task has been submitted. It will take some time to upload your classified image to your drive. So you have to wait for some time. So in this video, I have shown you how to import your training data and how to perform a classification, and how to perform the accuracy assessment for the classified image, and last, how to download your classified image to your Google Drive. So how to export your classified image to your Google Drive. So thanks for watching, and please subscribe to our channel and give us a like. Again, thanks for watching.